Hello everyone, welcome back to the channel. I am Nikhil Kumar. In the last few videos, we built a strong foundation on machine learning. We covered what a machine learning is, the difference between training and inference, and the major types of machine learning. Now it's time to move from theory to practice. And in this video, we will build our very first machine learning model. And don't worry, if you have never written a machine learning code before, I will explain every important concept step by step. And by the end of this video, you will know how to load the data, train a machine learning model, evaluate its accuracy, save and reload the trained model, and make prediction using new data. And if you are a DevOps engineer, don't think of this as becoming a data scientist. Think of this as understanding an application you will eventually deploy on the top of Docker, Kubernetes, OpenShift, or any other cloud platform. So let's get started. Before we start writing code, let's understand the workflow we are about to build. Every machine learning project follows a simple process. First, we collect data. Then we use that data to train a model. The training process creates a model artifact that contains patterns learned from the dataset. And once the training is complete, the model can be used to make predictions on data it has never seen before. And that's exactly what we are going to build today. We will start with a dataset, train our first machine learning model, evaluate how well it performs, save the trained model to the disk, load it back to the memory, and finally use it to make prediction just like a real production systems. By the end of this video, you will see the complete journey from raw data to intelligent prediction. So let's start by creating a dedicated workspace for this particular project. So for that, we can use the mkdir command. So mkdir ml-demo. So we have created a directory called ml-demo. So let's move inside this. So we will use this project directory where everything for this demo will be live. So now before installing anything, let's create an isolated Python environment for this particular project. In DevOps, we rarely install dependencies directly on the operating system. We isolate them. And Python virtual environments help us to do exactly that. So for that, we can use a Python 3 command. So Python 3 -m virtual env, and I'm giving a name that is venv, that is virtual environment. So let's hit enter here. So now we have created a Python virtual environment. If I do ls here, so we can see a directory called venv has been created. Now we will activate that environment so every dependency stays scoped to this particular project only. So for that we can use a command source. So source venv bin and activate. So now we are inside a Python virtual environment. And for a quick verification to confirm we are using the Python interpreter from the virtual environment, we can use a which command. So which Python. So we can see the Python is running from the Python virtual environment which we just created, that is a venv. Next, we will install the libraries needed for the today's machine learning workflow. So for that we can use a command pip install scikit-learn and joblib. So let's hit enter here. So basically, scikit-learn provides machine learning datasets, algorithms, and evaluation tools. And joblibs helps us save and load trained models. You will see both of these throughout today's workflow. And it will take a couple of seconds here to install these dependencies. So now both the libraries has been installed. But one thing I always recommend is capturing the dependencies early so the environment can be reproduced later. So for that, we can use a pip command. So pip freeze and putting into the requirements.txt. So this command saves all the libraries and dependencies under the requirements.txt file. So let's hit enter here. Now let's verify the packages and versions that were installed. So we can do ls first. So as we can see, the requirements.txt has been created, and to verify the content for the same, so we can cat this file. So we can see the joblib and the scikit-learn has been placed here along with its dependencies. So at this point, our environment is ready. So the next step is to train our very first machine learning model. And instead of writing code from the scratch, I have already prepared the script so we can spend more time understanding what each part actually does. We will first look at the training script, execute it, and then move to the inference using the trained model. So first of all, let's create a training script. For that, we can use a command vi train.py. Let me update the script here. Here's a complete training script. Don't worry if it looks like a lot of code. We will break it down into a small section and understand exactly what every part is doing here. Every machine learning system starts with the data, and here we are importing the iris dataset from the scikit-learn, and it's one of the most popular machine learning libraries in the Python. And this dataset contains the measurement of different flowers along with their species. And here, if you notice these two variables, x contains the feature values which are the input from the model learns from, and y contains the labels or the correct answer. If you remember the previous video on supervised learning, this is exactly how supervised learning works. During training, the model already knows the correct answer and learns the relationship between the inputs and the output. So before training any model, we need to evaluate how well it performs. And that's why we split our dataset into two parts. One part is used for learning, called the training dataset, and another part is kept aside for evaluation, called the testing set. Think of it like preparing for an exam. You study using your notes, but the actual exam contains questions you haven't seen before. Similarly, the model learns from the training data and is evaluated on unseen testing data. Next, we are creating a machine learning algorithm itself. Here we are using the random forest classifier. A classifier predicts categories instead of continuous values. So for example, includes spam versus not spam, fraud versus not fraud, or in our case, predicting the species of a flower. And next we are going to train our model, and this is the one of the most important line in the entire training workflow. When we call a fit, the model starts learning from the historical examples. It looks at the feature values, compares them with the correct labels, and gradually learns pattern that connects the input with the outputs. If you remember our earlier video on training versus inference, this line represents the entire training phase. So once the training is complete, we need to evaluate the model. So first of all, we generate the prediction using the dataset. Then we compare those predictions with the actual answers using the accuracy metric. Accuracy simply tells us how often the model can correct on data it has never seen before. And finally, we save the trained model using the job lib. Everything the model learned during the training is stored inside this called model.pkl. This file is known as the model artifact. And instead of training the model every time, we can simply load this artifact whenever we want to make predictions. Now that we have understood what every section of this script is doing, let's execute it. So let me save and exit, and let me clear out the screen as well. And if I do ls here, so as we can see, we have just created a file called train.py. So let me run this. So Python train.py. So let's hit enter here. So as we can see, it completed the execution and it created a model artifact with a name called model.pkl. So what this script has been done here, it loaded the data successfully, it created a training and testing data, it completed the model training, it completed the accuracy, and it generated a model artifact. So if I run ls-lh and the model.pkl, so as we can see, the training process produced our model artifact. This file contains everything the model learned during the training, and this is exactly what gets deployed in the production machine learning system. So at this point, the training is complete, but end users never interact with the training process. They interact with the inference. Training teaches the model, and inference using the trained model to make predictions. So let's move to the inference script. So just like before, I have already prepared the inference script. So let me create a file for the same. So we can use a command vi predict.py. And let me update the script here. So now let's understand what this is doing. So first of all, we are going to import the joblib library because we are going to use the trained model artifact in this particular script to do the inference part. And notice that we are not training anything here. Instead, we are simply loading the model artifact we created earlier. This is exactly how production inference service works. The model is trained once and then loaded whenever predictions are needed. And after that, we are creating a sample brand new input. These measurements were never used during this prediction request. The goal is to ask the model what species it thinks this flower belongs to. And after that, we are going to call the predict function. The predict function sends the input to the trained model. The model applies everything it learned during the training and returns its prediction. And this step is called inference. And at last, we are printing the predictions here. So now let's test the inference part as well. So let me save and exit this file. Now let's execute the inference script. So let me run Python predict.py. So let's hit enter. So the model loaded successfully and receives the input and returns the prediction. And that's the inference in its simplest form. So we got a response that is Virginica. We gave some different data set. On the basis of the data or the sample we provided to the script, it predicts the species of the flower. So now let's change the sample data in this. So let's open the predict.py file again and let me comment this line and uncomment this particular sample. So now let's provide a different input. We are using the same trained model, but the new feature values. So let me save and exit and let's run the same script again. So predict.py. So now this time we got different response. If you notice here, the prediction got changed, but we haven't changed the model. Only the input got changed. The model is simply applying the knowledge it gained during training to new data. And that's exactly how inference works in real world machine learning system. And if you would like to try this project yourself, I have uploaded the complete source code to the GitHub. You can find the training script here, inference script here, and all the dependencies needed to run this demo on your own machine. This repository link is available in the description below. Feel free to clone it, experiment with different algorithms, or even use it as a starting point for your own machine learning project. So let's quickly recap what we built today. We created a Python project, loaded datasets, trained our first machine learning model, evaluated its accuracy, saved it, loaded it again, and used it to make a prediction on new datasets. And if this is your first machine learning project, congratulations, you have completed your first machine learning workflow from start to finish. Now comes my favorite part. Everything we built today, it runs only on our local machine. But to use it in the real world, we need a much more. A REST API, Docker, Kubernetes, monitoring, scaling, and CI/CD. And that's exactly where AI infrastructure begins. In the next video, we will take this same model, expose it using FastAPI, containerize it using Docker, deploy it on the top of Kubernetes, and gradually turning it into a production-ready machine learning application. If you found this video helpful, hit like, share it with your friends, and subscribe for more content like this. Thanks for watching. I will see you in the next one.